And in this video I'm going to show you another template which is available on SmowCode, which is for the OCPP protocol. So what is an OCPP protocol? It is an open charge point protocol, which is an open source communication protocol used for electric vehicle charging stations to talk to a central system, which is like a cloud server or a backend platform. So how it works, an EV plugs into a charging station. The charge point uses OCPP to connect to a central system and send info like plug-in events, status, energy used, errors, etc., and receive commands as well like start or stop charging, update the firmware, config changes, and many more. So communication happens over WebSockets or HTTPs, typically using JSON or SOAP or XML files depending on the OCPP version. So let's see our flow. So this is an extremely useful protocol because electric EV vehicles are on the rise and it has a vast industrial use as well. So we have our on start node, which triggers when the system boots, and then we display Wi-Fi auto initialized in background, which is a log for the user. Then we display starting Wi-Fi, and then we connect to the Wi-Fi, which is named cabin 4. If you go to the properties, we have the SSID, password, the Wi-Fi config, and you can choose how many times it should retry if the connection doesn't connect in one try. So if the Wi-Fi is connected, we display Wi-Fi connected, then we display connected to OCPP, connecting OCPP, and then we use the OCPP connect node. So the OCPP connect node connects the charging point to OCPP central system using ID CPLZK99UJ. So you can use the charge box ID, you can put it in right here. You have the authentication key, in our case it's just key. Then you put in the OCPP backend URL, which is the server. You put in the charger model name, which is our ESP32, and you put in the charge point vendor, which is your brand name, and you can also put in a certificate if you want for authentication. And then we use display setting OCPP response, and then we use the set OCPP remote start transaction response. So this prepares a default response for when a start command is received remotely. If you go to the properties, there are a lot of functions available in this one node. So we are going to use remote start transaction for now, and the status is accepted. Then we use the remote stop transaction response, which prepares default response for stop transaction request. And then we have the set OCPP change availability response, which prepares response to availability change request from the backend. So this is our start flow, and then we have another flow which is basically an on OCPP receive remote stop transaction, which gets triggered when central system sends a stop charging command. So this is gonna display stop transactions and display the transaction ID with it. If the OCPP is triggered with when a backend message sends a generic OCPP trigger message, then the OCPP trigger message is triggered. We display the trigger and the requested message as well. If we receive a start charging request, then we display start transactions, the connector ID, and then we display OCPP library ran successfully again. So this setup can be a part of an actual EV system. It would get it connected to a Wi-Fi register with an OCPP backend. It's capable of remotely starting or stopping charging stations and listening for backend instructions like status updates, availability changes, or Wi-Fi triggers as well. So these are one of the most used nodes in OCPP and one of the most helpful nodes, as they are able to perform all the basic functions that OCPP can do. And there are many more functions available here as well, which you can try and see according to your requirements. So let me upload the code to our ESP32 and I'll connect the server and show you the requests from the server and how our ESP32 responds to it as well. So now I'm gonna upload our code to our ESP32 and show you on the serial monitor how we use this. I have already uploaded the code, and as you can see the serial monitor is open here. I'll disconnect that. So to run the OCPP we have a website which I'll share the link in the description, and I have already created a charging station called test charging station. You can do it and add your details right here. Then go to charge point, go to the test charge point 1, go to connectors, and you can print in the charge point details right here, which we have already used to connect to it. So the charge box ID is the same as the update as in the connector, and we have actions. And let's start our serial monitor. Let's clear the output, let's connect it to our ESP32, and if I start the charging, you will see that we have a message which says trigger start transaction, which means that it has received a trigger to start a transaction remotely, remote start transaction here as well. So it starts the charging station, and if you want to stop charging, we have one here as well. There are different triggers which are received by the ESP32 as well from the remote website. As you can see here, it sends and receives various signals as well. So if we click on stop charging, you'd see that it has received stop transactions as a transaction ID, and we print in the transaction ID here. Remote stop transactions, transaction ID is printed right here. So this is how you use OCPP on SmowCode, and it is extremely useful and a growing protocol in the day and age where electric vehicles demand and supply is growing tremendously.